All right, Walt, Rogers, and Gudgel, they're retired Weather Service aviation forecasters. And they've really been active in forecasting for soaring competitions and special projects. Their presentation today will cover strategies for delivering operational weather briefings to a pretty unique aviation activity. Going into some of the products and software tools that they use for their soaring forecast. Let's see, we also have Dan, very experienced tow pilot and designated pilot examiner for gliders. Walt flies competitively in his Discus 2A sailplane, and both have supported world gliding competitions and the world altitude, setting the Perlin glider in 2018 and 2019. All righty, Walt, it's all yours.
Okay, well, thank you very much. I need to do a little fiddling here to get this set up to share my screen. I have two monitors, so I want to make sure this works. Share screen. Uh-oh. Where did the little orange bubbles go? Hello, am I on?
You're on, Walt. So we had your screen before. Looked like then you went off to the other one, possibly?
Wait here. I have to start. There we go. Slideshow from first slide. Okay.
There you go.
Which screen do you have? Do you have the full slide?
We actually have the notes side of the screen.
Okay. Well, I need to change that to the other screen. Share window. Select window. There. Why?
It's coming. Just give it a second.
I couldn't really test this at home. So is it sharing the proper slide? I have a box around it here which truncates it.
It does look like it's truncated right now, but let's just give it a minute and see if it'll catch up there. Okay, it's coming up.
Yeah, but the window it has around this, the box, is only 2/3 of the window on my monitor.
If you expand your window to full monitor?
Well, Join Me doesn't have an expandable window. I just pointed at this window and it's not working. Come on, I get to have technical difficulties too, okay?
If you actually expand the window that you're using, Join Me will expand with the window.
Oh, let's try that. Okay. Share window. Slide. Start from first slide. Please, God, please be good to me. How's that look?
We're going to give it just a minute here to make sure it catches up.
Has it caught up yet? Do you have the full slide?
I'm seeing comments saying, it's actually not looking clear on my end, but I'm actually seeing comments coming in from the chat that says it's looking good on other people's end. So I would say go ahead.
Okay. Actually, let me hand it over to Dan Gudgel.
Yeah, good morning. We're going to see how this works. Anyway, Walt and I have worked together for, I guess I dare say, 4 decades. So I'm going to start with my personal background just to give you an idea of what is near and dear to my heart as far as that goes, is the specialty programs. But my background was in aviation and agriculture even before I got into formal meteorology. And it matched nicely with my weather service career, and I would encourage other folks who've got backgrounds like that, since I'm addressing meteorologists, to get tuned into what we call the specialty programs. But my family was a fixed base operation involved in flight instruction, charter, maintenance, ag, aviation. I also farmed. I held flight instructor certificates through my weather service career in rotorcraft, airplane, and glider categories, including, as mentioned, I also served the FAA as a designated pilot examiner. Besides the formal education in meteorology, through 36 years, I worked primarily in the Intermountain West, as Birch knows, including a stint there at WSO, WSFO, WFO, Reno. I was 2 years at the Office of Meteorology, working in headquarters in the Aviation Services branch, interestingly enough, where we set the policy and procedures for aviation nationally. And then I had the honor of being one of the startup warning coordination meteorologists, which at the time was the operations chief of the new WFOs. And to give a plug to the Intermountain West, very biased that I am, our service to specialty programs was the original decision support, ag, aviation, fire, marine, air pollution, and personal contacts with emergency managers to the meteorologist here in the Intermountain West. In aviation support itself, Walt and I ended up excelling at what we call remote event support. Anything from we used to hand plot RAOBs to the latter stages where we use the advantage of our so-called temporary AWIPs set up at remote locations.
Our portable AWIPs too here in the best western California.
So 4+ decades of local, regional, national, and international contest support, including 2 World Soaring Championships, working with Walt, and he's got me beat because he worked in a World Soaring before that. So in these special events, I utilize not only the meteorology, but my other skills as a tow pilot and instructor, relating very nicely with the aviation community. So aviation weather support for soaring itself is got an emphasis a little different from the standard aviation weather brief. We don't concentrate so much on the classic FAA briefing products as we do on real-time weather information, as well as excellent short-term detailing forecasts for a contest day. We're a subset in this category of soaring. Now, to give a lot of credit, Reno is one of these. It's a boilerplate for service to soaring entities, both in serving their local area, and then they get contests, which I have labeled there as transitory as they come through the area. So what's needed is that for folks to become familiar and knowledgeable of aviation operations. If I could give a shameless plug, it does help if you're a pilot. It has served Walt and I well because we immediately related to the customer or the customers we wish to serve. Now, for soaring flight, what's needed is that, obviously, we want to study the 4 lift types. So as a meteorologist, you know about ridge soaring, thermal soaring, mountain waves, and convergence. The interesting thing is that the engine for the soaring flight is obviously these lift types. It's not trivial as far as their performance. They can fly 14 hours duration during the heat of the day if we're looking at thermal. They're even now flying at night in some of the mountain wave. They have exceptional speeds with no engine. The record right now is 190 miles an hour in an hour. It's flown primarily in a mountain wave by a counterpart there in Reno, Nevada, Minden area, Jim Payne, and 75 miles per hour in thermal flights over 750 miles distance. And as alluded to in the introduction, the recent record in soaring, the Perlan glider, flew to flight level 764. For the layman, that's 76,400 feet with an airframe target capability, I think, of 90,000 feet.
Hey, Dan, I'm so sorry to interrupt you there. It looks like your slides have actually frozen up. We haven't seen any slide changes since you began speaking.
Okay. Let's see what we can do.
What slide is it on? The first slide?
We have it on slide 3 right now.
That's the one that shows aviation weather support?
Yes, but we've been on there since the beginning. It's actually not in presentation mode. It's showing the slide itself.
Well, interesting.
If you try going into slideshow mode, would that work for you?
I am in slideshow mode, but it's another one called console, where we can see the console speaker notes. Don't worry about my speaker notes. Just go ahead and put on yours, because I've got mine running to the side. Is there any switching at all of the slides right now?
No, there is not.
Okay, the slide you have is slide 3. It's headlined Aviation Weather Support?
Yes, sir.
Okay. Stand by 1.
Thank you.
Put me to that one.
Again, sorry for that interruption.
No issue. If need be, my portion can continue through, but Walt's going to need it for his detail work.
Well, we can get out of this console 2-monitor mode. It might be confusing, this join me thing. And we can try that without our notes.
Kill that. Don't worry about the notes. Go there. No? All right.
What is the name of the slide that you're seeing now?
She says aviation weather support.
I suggest we get out of the console presentation mode and just go to one screen. We're gonna change modes here. Unplug that thing. Try something a bit different here.
While Walt is bringing the screen up, I'll continue, because I think this could be carried easily enough. The soaring flight, like I said, is different from the traditional FAA weather briefing needs, all right? So it behooves the meteorologist to understand the lift capabilities of the atmosphere. And the other thing I always like to point out is one man's gold is maybe another man's trash, but the mountain wave condition is typically contended to be a hazardous weather event for briefing purposes. But actually, the soaring pilots are going to ask you where it is and what's happening with it, because they use that as a form of lift. Where do we stand? Do you see basic pilot?
It's starting to catch up there, just letting you know.
Okay, thank you. So anyway, the most interesting thing and most complex for the lift types is the convergence multifaceted lift process. It's primarily density-driven winds interacting with terrain and makes the intermountain area quite diverse for soaring. Personal observation and a bias, and I've confirmed this through a number of international events or underscored it. The Intermountain West is superior over other parts of the nation and even the world on any given calendar year. And so therefore, soaring in the western United States is very, very popular, and at any given time, likely to find some lift conditions of one form or another. First of all, on site, if you're remote, or if you're at the office, the data access is extremely important in the modern era. But I got to say something here. The radiosondes remain very important due to the temperature resolutions coupled with our models. The profilers, not so much. The meteorological parameters needed, because we'd like to forecast for thermal lift. It alone pretty much provides a relatively homogeneous lifting environment for a task area, for a contest, or for somebody wanting to fly a long-distance flight. So thinking about that, for the thermal lift forecast, working with a competition director, you know, you're going to want the sky conditions, you're going to want the initiation time of the temperature, subsequent height, and the strength evolution to get them launched. You're going to want to forecast the maximum altitude you think they might reach, the strength of the thermals, and of course the time of day that occurs. The last useful lift is important. It helps in the task planning if you know the length of the day. The launch time conditions are not trivial. They've got to know ahead of time to stage 50, 60, 70 gliders, and then for the favorable wind direction for aero towing the glider. So you've got to be able to forecast the proper wind direction for the launch. Winds aloft are important, thermal shearing, cloud movement. And even the impact of the cumulonimbus anvil can shadow a task area that's been assigned and knock down a whole class of gliders. So right along with the modern attack on forecasting, threats, probabilities, forecast confidence, these are all given in your role in assisting a competition director in that risk assessment and decision making. And then it's needed also, you need to know the recovery conditions, because the gliders will come in from a variety of directions perhaps, and they need to know the landing runway. Additional support.
Sorry to interrupt, guys. It looks like we may have lost your audio. All right, let me just try 1 minute here to get you back up. I'm not actually seeing you in here. It's possible, I know you guys were going to be calling in remotely, and it might just be their internet connection that's gone down, so I'm just trying to see. Yeah, it looks like we may have had them drop off here. We'll give them a couple minutes here to see if we can get them back. Again, I know that they're actually planning a flight for this afternoon, and we're going to be out remotely, and we're hoping to hop on a hotel Wi-Fi or a Starbucks Wi-Fi. Although, honestly, I'm not even sure how many Starbucks are allowing sit-in customers yet. So, again, we'll just see if we can get them back up. And if for some reason we're not able to get them back in a minute or two, we will go ahead and move on to our next speaker, and then we'll have them come back and join us after that. All right, I'm attempting to get a hold of them right now. Looks like Walt was able to take over as presenter again. Let me double check. I know your guys' audio. Make sure. It looks like we don't have an audio connection right now for you, Walt, if you can hear me. Since I see you are able to take control, but we're not getting your audio feed, Walt, I'm going to be private chatting you a phone line that you can call in on, or feel free to send me a chat as well to let me know if there are any problems. 1 moment, please. All right, Walt and Dan, you should have a private chat that would have lit up your second bubble from the left that has phone information to dial in if you aren't able to do audio right now. All right, Walt, I'm actually showing audio again on my side. Are you there?
Okay, I'm back on your. We got
Perfect.
kicked off the session, and I finally just got it set up again. We didn't realize that.
That's okay. I was trying to get a hold of you there, but looks like we're good. You guys, thank you for your patience, and please carry on.
Okay, I need to get out of this presentation. Okay, let me know when the first slide comes up. I'm Walter Rogers, retired.
We have you.
You've got me? Great.
Yep.
You can see my introductory slide. I retired back in 2010 at 42 years when National Weather Service. I ran the ZLA Center Weather Unit just before I retired. And I'm also a very active competition pilot. A little less so. I just turned 70 years old, but trying to stay active. I've done support or briefings for 3 World Gliding Championships. And just recently, as Dan pointed out, he and I together supported the Pearland project in the last couple of years. The point of my talk is just to show you what the tools are that we've used in the past and where we're heading and where we are now for doing soaring weather support. Radiosondes, paper drawings, to global web services for gliding is where we're at now. And even the mountain waves that are detectable through the high-resolution models like the WRF and HER model. I'll talk a little bit about the tools I use, observational sources that are favored, and briefing formats that have been very, very effective in this current era. Well, I can't really say all of you know about the days of paper tape and teletype and hand plotting SQT diagrams. Maybe a few of you out there remember that. Twice a day, hundreds of kilometers apart for radiosonde obs, we used to calculate the thermal heights. And it's just not a very effective region because it's hundreds of kilometers away from where you're going to be gliding. Here's an example of the Boulder NOAA interactive SQT site that plots a RAP model sounding in purple with the black radiosonde observation. And you can see we'd prefer to have the high resolution soundings everywhere and all the time, but we're dealing with a somewhat smooth sounding from the model, but it's the best that we have. So today, for regional, even local flying and international events, we're all relying on these 4 main services. The top one from the United States that I use the most is called SkySight. And they actually have 16 global regions around the world with other soaring regions. Top Meteo was founded in Germany about 25, 30 years ago by a professional meteorologist and numerical modelers who are also glider pilots. Some paraglider pilots formed XC Skies, which is the 3rd one there on the list. Chris Scally at the University of Utah and his fellow pilots, and in this case paraglider pilots. He has an excellent site. And then finally, the founder of all this in the United States was Dr. Jack Glendening, who formed something called BlipMap, which was the first use of computer models for soaring forecasts. I'll show a little more in a second. Soaring sites, Top Meteo. This is a sample of what the graphic looks like. I can't really show you very much except to say that they have a series of 2D graphics with thermal heights and cloud cover. I know you can't see on this diagram very well, but these are 2 digits, hundreds of feet of thermal height with little depictions of cloud cover by the shading and icons. This is the group of meteorologists, Dr. Bernd Goretzky on the far right and Bernd Fischer, great guys. This is the premier site for Europe and Africa. South Africa is actually a very active international gliding site. They do gliding graphics and a service for general aviation and ballooning as well. So they have a web service. It's about $99 a year for 10 regions in the United States with GOES 16 imagery. You can tell this is a little old. It said 15-minute intervals. We all know it's 5-minute updates. What they do is they use the GFS model to initialize a regional model 4 times a day, and that way they can get soaring forecasts out to 6 days. It's designed to be very easy to use for glider pilots who just want the answers, and georeferencing is a little dodgy in my opinion. But moving on to the other web service that is not widely used but is still quite good, it's called XC Skies. They're now using the HER model, the NAM 3 kilometer, the NAM 13, which is practically a deprecated service now, not quite, GFS and so forth. It's $40 a year. And from my fellow glider pilots, they've generally considered this a little too technical for them. You can plot on the of heights, the cumulus cloud bases, wind barbs, a lot of information, and you can compare the graphics. It's not as easy to use, but if you're a meteorologist, this is really a top site for looking at soaring parameters. The founder of all this web soaring services, Dr. Glendinning, Dr. Jack, we call him, started a service called RASP, Regional Area Soaring Program. Essentially, it's the WARF model running on a PC. And individuals that are technically astute or learn how to do it set this up and run their own soaring forecast on a PC. There's still a few areas around the world that use this, and it's free. But as everybody knows, nothing is free. It takes a lot of time and effort to set this up and maintain it. But it's one of the 4th alternatives, open source, you could call it. The site that I favor is SkySite, and Matthew Scudder is a young Australian racing pilot who won the Junior World Championships in 2017. He quit his Google software engineering job to start this service, and now he has about 16 regions around the world that he forecasts for with soaring forecasts. And he's moving into ballooning and general aviation as well. A lot of confidence in this guy, besides being a racing pilot, to end his Google professional career and start his own business. In the gliding world, we look at soaring parameters. It's generally height of the thermals, where thermal index equals 0, and something called the usable lift, or HCrit, critical height. It's slightly lower than the maximum thermal height. That's a separate parameter that's plotted in all these services. Cumulus cloud base based on lifting condensation level. And the big one with SkySite is he has a graphic that shows convergence zones and shear lines. And finally, thermal strength, W star, which is based on the boundary layer parameter on the surface heat flux. Any rate, the screen looks pretty much like this. You have a slider at the top where you can pick any 30-minute period during a 12-hour day from 8 a.m. to 8 p.m. On the left, Dr. Jack's soaring parameters. In fact, Matthew Scudder in SkySite is using the identical library up until recently to calculate these indices for soaring. And then you have a transparency slider for map backgrounds. There's many, many more features to this graphic, to this service, which I'll point you to in resources later on if you want to learn more. One of the things you can do is point at a location and get a time series plot. The top time series graphic is soarable height, and the slightly faded line is lifted condensation level. You have surface temperature, dew point, surface winds, and you can get this for any site and by just clicking on the point. You can also get skew-T diagrams and a host of other things. One of the unique advantages of SkySite is it's giving us the vertical velocity from the gravity waves, from the mountain waves. And here's an example where you can create a cross-section. In this window on the far left, you see a line across the Sierras, and the vertical velocity on the right window, where the purple is indicating about 1,000 feet a minute lift. And nope, the bright areas, red, are up, blue areas are down, I believe. At any rate, this is what we used in the Pearland project. Here's one of the graphics we used in 2018 for the world record flight in Argentina. The Pearland project contracted with Matthew Scudder's SkySight to have a region of high resolution model down there. And the black squiggly lines are of a track in the lee of the Andes Mountains, and they were searching for the lift. And the right graphic there is a vertical cross section through another WRF model that was contracted with a company called Weather Extreme Limited. There you can see the gravity waves at 18 to 26 kilometers, actually stronger. The red horizontal line at the top there is flight level 76,200 feet or so. And that's as high as they got. You notice the waves do go higher. And if we can go back there again, I expect we will get higher with these stratospheric waves. Another tool that I love to use because it's fast and easy once you get the hang of it over the hump of the user interface is BuffKit. It uses buffer or BuffKit text model soundings from all the NOAA models. You can plot a host of information on there for mainly severe weather, things like that. But the yellow line at the bottom are the mixed layer height or thermal height. And you can very quickly get the thermal height from these model soundings with hourly time resolution. And it's very useful, very fast to get the winds and details in the boundary layer. Notice the time on this increases by going to the left. The other tool that I like to use is a program, a PC program called RAOB, or it's on the website raob.com. And I've written some scripts that plot what they call thermal index. The white, you'll notice that by the way, the time increases from left to right on this, and it's hourly. And the white band near the top of the boundary layer there is thermal index equals 0. So you have a sense of plus or minus 2 degrees C of how high thermals would go, and give you a confidence factor on that based on the sounding. Also, there's a green line on there with the cumulus cloud base and temperature and surface winds. This is very time-consuming to do if you have to use the user interface to do each sounding in each model, but I have written some scripts that make it very fast because time is critical in the morning when you're doing a weather briefing. GOES 16 and 17 is a godsend for looking at the details of cumulus cloud streets. This was an example of a case in back several years ago in Florida where they were having a contest. And I'm not going to show you the video animation, but what this satellite photo shows is a 5-minute animation of the GOES 16 visible red channel and overlaying a sailplane on there with its track. And you can, if I had time and ability to do this, you could see the glider's track following the cloud streets and shifting as it moved along the course. This is a very useful thing, not for operational forecasting, but for diagnosis, because it takes a program called Integrated Data View, or IDV, to calculate these things. More information in the resources if you want to know what that is. For radar observations, I like to use RadarScope. It's an app on Android and iPhones, iOS. It's also available on Windows and Mac now. But for something to have in your hand that gives you professional quality NextRad data, I consider this the top one. It has very low latency. It's single site for each radar, so it does not mosaic the data. But that gives you the advantage of knowing you're looking at pretty close to the raw data for interpretation. And those of you in the National Weather Service who've used NextRed, I would think would appreciate that. Here's an example where it's showing the outflow boundaries, the low reflectivities, which would be very useful for gliding, especially if you're sitting on the airfield with 60 gliders getting ready to tie down for the night. We want to know if there's a gust front that's going to come through and if there's any lightning data. And radar scope can give you all that right in your hand. Sea breeze fronts are illuminated here in the lower right diagram. For general usage of NextRed data, I like the MRMS multi-radar, multi-sensor site. This is their operational product viewer. I know you have this in AWIPS 2 now, I think, and it's pretty widely used in professional meteorological circles. But this is really great because you can go back in time to weeks, months ahead and pick whatever step rate you want, 4 minutes, 2 minutes, hourly updates, and find out what happened with radar and showers, thunderstorms and shower activity. So, boy, here I am at the end. This is a good thing, I think. If you want to know more about this, I have a host of presentations I did at a Soaring Society convention, and it's listed as the second line at the top of the screen. In that screen, there are a host of other presentations and videos with more information. There's a presentation from the top Meteo people and SkySight people. Perland Project, if you want to learn more about that, great website with lots of detail, perlandproject.org. And the video in this link below here is a 2.5-minute synopsis of the world record flight and the project, which is a compact way of really getting a sense of the camaraderie and excellence of that program. For collaborative briefings, I'm relying now on a collaborative web server, an open software called codymd.org. And with that, I create my presentation. It's not in slide format. It's simply a document with text, graphics, and video links. It's using a markup language called Markdown. If any of you have ever heard of that or used it, it's very fast to create. And I can create a presentation with that and share it very quickly to people who are viewing this on smartphones, tablets, or PCs. It adapts to whatever format they're displaying on. I tried to get it in slide format, but the problem is it just took too much time to format it. And I literally have an hour and a half to 2 hours every morning to do this. And when you're a competitor, which unfortunately I tried to compete and be weatherman, which I don't recommend, too busy in the morning, this gets the job done. And in that link there, you'll find information about how I distribute it. I use another program called Calling Post, a web service for simultaneously sending text messages and emails, which greatly reduces the amount of time it takes to get the word out. So let me end it there, and thank you very much for inviting us to do the presentation.
Thank you so much, Walt and Dan. We will go ahead and open it up for questions now. I already see one question. The question is, I fly airplanes with engines focused on getting some places instead of soaring. How could I use some of this data?
Well, there's lots of ways you can use this data. For one thing, if you want to reduce fuel consumption and you're flying along the Sierras, you can fly in the right part of the mountain wave and save half of your fuel consumption. If you using SkySight, for example, or there's websites that show the HER model that also have the vertical velocity from mountain waves. The
It looks like we may have lost Walt there. Let me see one more time if I can actually unmute them. I think I've...
Okay, thank you very much. I guess,
Sorry,
Sarah,
Walt,
you're on.
briefly muted there for a second, but we got you back on. Thank you again, Walt and Dan, and I pass control over to Sarah. And let me go ahead and mute Walt here. And Sarah, are you able to have audio right now? Actually, I hear myself in your speakers, so yes, I guess you can.
Yes, I do have audio now. Walt handed over the presentation role and coming up right now.
Yeah, we can see your slides. So introduction here for Sarah. She is the newest emergency response specialist and meteorologist at the Western Region ROC. Previously, she had worked at the Salt Lake Central Weather Service Unit. She's the co-chair for IWAWS. And we will let Sarah take it away.
All right. Thank you very much, Don. Like Don said, I'm kind of new in this role as the Emergency Response Specialist, or ERS. I had been at the CWSU for about 11 years, so that's where I'm coming in from my aviation background. One of the things I enjoyed doing at a CWSU was interacting with the controllers and trying to figure out how to share relevant weather information with not only controllers, but pilots. Because I decided that if I wanted to help a controller have a better day, an easier day, I needed to be able to get pilots the information so that the controllers weren't having to get pilots out of trouble that they never should have been in. And if they would have had the right information, maybe we could have prevented something. So with that, got into social media aspect and how pilots could utilize social media to enhance their weather information. When I was going about this, my former boss, his name is Rick, said, the title of your presentation like this should be, Get on Twitter or You're Stupid. And we decided he was not allowed to give presentations. We were going to keep him in the CWSU and not let him out. So I kind of went with a different approach. Are you missing something? How the National Weather Service web pages and social media accounts can give you a better picture, a more complete picture for your aviation weather awareness. Basically, as pilots and aviation weather users, this is about you. We want you to be able to find out the information that you need, not the stuff you don't care about, not the things that as meteorologists and scientists we think you should care about. Well, there's a few different ways to do that. Social media pages can be customized so that you can follow and like who you want. And if you don't need it, you can unclick it, unfollow it. It is no longer part of your world. The National Weather Service forecast offices and CWSUs, along with the national centers, a lot of us have Facebook and Twitter pages, and we try to share that information, as we get it. In general, we think local is better. Take advantage of what the free options are, and take advantage of that local expertise that these forecasters have been gaining in their time in their offices. So taking a look at a few of the social media stats. Now, when we look at offices like Reno, like Salt Lake City, their Facebook followers, Salt Lake City has 31,000, Reno has 64,000. When it comes to Twitter, Salt Lake's up at about 27,000, Reno's at 31,000. Now check out your CWSU locations. For example, for Salt Lake, 3,500 for Facebook and 3,100 for Twitter. And this was a few weeks ago, middle of May. Aviation weather users are a smaller group of people than the general public. However, you're more knowledgeable than the general public. So when it comes to the weather questions that we get from aviation weather users are much different than the ones we get from the general public. And we are grateful for that. One of the things we kind of have to remember is, where am I? And when we look at the National Weather Service and our geography and our organization, as you've seen, we use lots of acronyms already. We have lots of different offices, lots of different breakup groups. Jane this morning pointed out that she was at the Great Falls forecast office, Central Montana. That's they've got a pretty big area of responsibility. When look at the I guess Ken showed you earlier what Oakland's Center of Responsibility looks like, and there includes the oceanic area. We're talking about landmass. You start looking at Salt Lake and we go from the Canadian border all the way down to southern Utah. So I had blizzard conditions, strong winds, a little bit of flooding, fire weather, and thunderstorms all in the same day at the same time as aviation weather concerns. If you're in Montana, you don't really care so much about the Utah fire concerns unless you're going to Utah. What is the role of a CWSU, a Center Weather Service Unit? That's an acronym that I'll repeat a couple times, mainly because working in a CWSU and surrounded by air traffic controllers, they could not tell me what CWSU stood for. Our role there is we want to produce regional graphics and forecasts that utilize local expertise. So Jane in Great Falls is going to have a much better idea of what's going to happen in a TAF for Great Falls or Helena or Cutbank than I will have in Salt Lake City. We want to disseminate other weather service data. We want to utilize that local meteorological expertise and that specialized experience that they have. We want to take advantage of what the Storm Prediction Center is coming out with. That's a national center, but it's filled with severe weather specialists. We want to take advantage of what the Aviation Weather Center produces, and you've heard AWC mentioned several times, along with what their website has. Again, a national center. We coordinate with our neighboring CWSUs. For Salt Lake, that includes Seattle, that includes Kenover and Oakland, includes Palmdale, the LA Center. We go east to Denver, and we also coordinate with Minneapolis. In general, we want a consistent and collaborated message. If you look at multiple offices and see multiple forecasts, what's your confidence? Mine personally is going to be low. I want to see something that's consistent. I want to see some collaboration in there. The role of a weather forecast office, and I have some past experience with that as well, in Lake Charles, Louisiana, Jackson, Mississippi, and Northern Virginia that served Washington, D.C., and Baltimore, Maryland. In that role, we produce local public and aviation forecasts with that local expertise. We know that this time of year, this airport is going to see a wind direction of this. We know that fog might be a concern this type of year, where it might not be just a few miles away from the airport. In a weather forecast office, you have forecasters available 24/7. In a CWSU, it's smaller staff. On a forecast office, outside of COVID conditions, you have more staffing and more people to do different roles. A lot of the role of a WFO is coordinating with national centers and regional centers for that consistent message. With any great new thing, there are some weaknesses. One of those weaknesses, especially when you look at CWSU and WFO social media presence, is the staffing. So CWSU is staffed with 1 meteorologist on duty per shift. They have a total staffing of 4, 1 manager and 3 forecasters. Can hit the apocalypse of a CWSU with a sick leave hit, short staffing, so they have limited staffing for the next week. A weather forecast office has usually about 10 to 12 forecasters on average. Certain offices are a little bit more, a little bit less. But even with that increased staffing, they have to put forecast and warning operations first. That means that social media pages are not necessarily going to be updated at all times. That's why you want to still use their individual websites along with social media. So let's consider a trip. I'm thinking about flying from Seattle to Reno, and not me personally because I'm not flying into Reno, and then on to Salt Lake City. Well, looking at the Weather Forecast Office, the WFO, look what I'm going to be crossing. I go from Seattle through Portland, through Medford, a little bit of Sacramento area maybe, Reno, Elko, and Salt Lake. That's a lot of pages to check, right? You're going to click on each individual forecast office's website. When I look at the CWSUs, I go from Seattle to Oakland to Salt Lake City. Still a pretty large amount of airspace, quite a bit of topography in there. If I'm considering the national centers, I'm looking at the Storm Prediction Center and the Aviation Weather Center. What am I going to see when I start looking at, say, social media? So I picked a few Facebook page sites, a few Twitter pages, and started noticing the difference between what a forecast office could publish and what a center weather unit could publish. So at the top right, I have the CWSU Seattle social media page, and this is one of their weather stories, their graphics that they put out just about each day. They're talking about lower clouds, mentioning the pale blue outline. That's going to affect parts of California, Oregon coast. Elsewhere in the region, mostly VFR with high clouds. Not something you'll necessarily see on a forecast office page because usually they don't reference aviation conditions as much. One of the roles of the CWSU, especially on social media and some of our graphics, is to take that public forecast and apply it to an aviation mindset. So if I'm going to look at the office in Pendleton, Oregon, unsettled weather starting Sunday, impact the briefing of the week. And this I created these graphics or pulled these graphics a couple of weeks ago. So they're starting to look at showers, thunderstorms, maybe a little bit of hail. That's going to be something I want to include in an aviation forecast and talking to air traffic controllers or pilots. Later on, Pendleton wrote showers and thunderstorms possible. Showers possible thunderstorms expected for the inland Northwest Tuesday and Wednesday. And they put a couple different hashtags, so depending on how you've set up your Twitter account and what you're following, that can maybe attract your attention. They give you a little bit of the why. A low-pressure system off the Pacific Northwest coast will move through the region over the next several days. Unsettled conditions, including widespread showers, slight chance of thunderstorms, and gives the location, eastern Oregon, southeastern Washington. General outlook, but as a pilot, you might think, okay, let's see if I can avoid that area. What else? Where else could I go? Los Angeles office, we're talking about gusty onshore winds impacting the Antelope Valley one day. That would have been a Monday night and a Tuesday. And they're stronger winds, 40 to 55 mile an hour gusts. So strong crosswinds blowing sand and dust, creating dangerous driving conditions. Well, what about for a pilot? Well, reduced visibility in that blowing sand and blowing dust. Strong crosswinds might indicate increased turbulence and potential for low-level wind shear. Reno office, they actually highlighted blowing dust and strong thunderstorms and included something expired on their graphic. That lets you know that's a little bit old. And then Medford also highlighted the blowing dust. Not all offices are that in tune with blowing dust, but it's getting more of an awareness from the forecast office standpoint, and the CWSUs are acknowledging that as well. So again, this is about you. What kind of information can you use? So Facebook, Twitter. If you look, there is a social media page that the Weather Service has that I will link to in the chat. I thought I had included it here, but I may have deleted it. Many offices have Facebook and Twitter, though not all. So we'll, select few offices don't necessarily have that. Try to take advantage of those local offices. One, it's nice and free. See what you can use from there as you get familiar with their websites and what type of products the office issues. So if they issue a blowing dust advisory, if they issue special statements about blowing dust or different threats that could apply to aviation, those would be good to follow if you're flying in that area. All right, I have some time for questions. Looking at, I follow NWS on Twitter and love the alerts, especially on AirMets, and soon I expect SIGMET. Those are experimental projects. A lot of their social media graphics for those are experimental, especially the SIGMET. But notice those are really helpful, and when I was at the CWSU, I would share those as soon as possible to get that out to the pilots. And usually could print their graphics to give to the controllers as something visual they could see rather than just the little statement that they read. Is there a cheat sheet that tells us which office produces which product? Probably depends on the product. You have different aviation discussions that Ken put in the chat. Each office writes a little discussion, and that gives you a little bit more of the where, the why, and sometimes the confidence level, which is very handy. I said, let's see, for Viewer 54 cheat sheet that tells us which office produces which product, might need a little bit more information from you when it comes to how to answer that. Part of it might be our terminology in the Weather Service and how we think of products and services. From a CWSU, all CWSUs issue center weather advisories. Sometimes it's things that aren't quite covered in a SIGMET, such as thunderstorms, maybe a smaller area of thunderstorms, or developing thunderstorms. Varies a little bit by office. Also issue a meteorological impact statement, or an MIS. For Salt Lake Center, sometimes we usually focused on winter a lot. Sometimes would focus on high density altitude, which is more of an aviation concern than a public weather concern. So you're not going to necessarily see that on a WFO website or social media post, but you would see it more in a CWSU post. And usually they'll associate that with a heat graphic as well. That's one of our triggers to what we'll talk about when it comes to high density altitude. Are there any other questions?
I'm not seeing any on my end, Sarah. Great job. Thank you so much. Steve Van Horn, I'm going to be passing the presenter role to you and getting you set up as Sarah spins down.
And I got it within the time. Phew. All right, that is done. Come here.
Yeah, I can see Steve taking control. Let me make sure you have audio, Steve. Now it looks like you're muted. 1 second, please.
Okay, can you hear me now?
You are good to go.
All right, and you see my screen?
We can, thank you.
Okay, great.
And let Sarah actually do a quick introduction on you.
All right, thank you very much. So, Stephen is a forecaster at the Weather Service Forecast Office in Spokane, Washington. He has over 10 years of forecasting experience for that county warning area. That includes much of eastern Washington and northern Idaho. Before he joined the forecast team at Spokane, graduated with a master's degree in atmospheric science at UCLA, and completed an apprenticeship in what we call a SCEP program, Student Career Exploratory Program, at the Weather Service Forecast Office in Oxnard, California. So he's the aviation program lead for Spokane, working on projects that enhance